All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.
Have you been encountered with a situation in which there is a water in one part of the washing machine and you switch on the dryer? The machine shakes, and overall, if you look at the water, it will show you a particular pattern. The water is going up and down, but the wave pattern in that water remains the same. Hello everyone, I am Sachin Kumar. Welcome to S.chand Academy, and today in this lecture we are going to study about the standing waves. So overall, a situation in which there are two walls or there are two dangling walls, somehow the wave is going and coming back and overall trapped in that situation. So there we get a phenomena like standing wave. So we are going to study about this. If you wanna study in depth about these topics, you can refer this book by S.chand Publishing. You can also find its ebook links in the description box. So let's begin with the lecture. Standing waves. The same case of a washing machine, next time I guess you are going to observe it for sure. There are two walls or there are four walls overall, and when a wave of water is going, striking and coming back, overall you find a pattern of standing waves. So basically the phenomena of standing wave starts with the concept that we have two places, and between these 2 points the wave is somehow trapped. Now the condition is, one thing is, when this wave is trapped in between these 2 points, or even it is bound at one point, one side it's open, so even then in that case also we can study a standing wave, but presently we are focusing on the situation when we are bound at both the points. Now either there is a string in between these two walls, and the property of this joint can be like this, that this string is fixed at these points. So this could be the one condition. The second condition could be that you have a string between these two walls, or these are not in fact walls but some vertical poles, and on these poles you have these rings. These rings can go up with the wave and can come down, and the reflected wave will start going back. And the third case is a mixture of both, in which in case of one wall you have this attached to the wall, the string is attached to the wall, and its second end is a ring which is on this pole. So overall I can say that in this case its ends are fixed. So I can say that this is fixed ends. In case of fixed ends, this is the expression, and the another expression we are going to find out for a free end. So in this case you have a wall and a string is attached to this. You transverse a jerk to it, and this jerk moves towards the wall and then reflects back. Now you can write down the incident wave function as psi I, which is a function of x and t, and which is equal to a amplitude, and the real part of the exponential term e raised to power iota some phase. So we can write only its real part as cos omega t plus kx plus phi. So this is a collective term in which kx is one term, phi is at t is equal to 0, what phase we have taken, and omega t is the change in phase with time. So this is the overall wave function in case of incident wave. Now let's talk about what is the reflected wave. So the reflected wave, we know that so this is a function of again x and t. So the reflected wave is equal to the coefficient of reflection, which is we have studied in our previous lecture, which is equal to C2 minus C1 divided by C2 plus C1, in which C1 and C2 are the velocities of these wave in their respective media. Now this R into this wave function psi incidence, and if I revert its sign, I reverse its direction, which is from x to minus x and t. So overall, using this relation, I should get this reflected part. Now because there is no string at the second part, minus infinity to 0, that part is okay, and after that there is a wall, no wave is transmitted, the whole wave is reflected back. So in that case, you will find that this reflection coefficient should be equal to minus 1. Fine. So C2 minus C1 divided by C2 by C1. So C2 is 0 in this case. So C1 by C1 cancel out, and overall you get this sign, R is equal to minus 1. Now when we apply these conditions in this expression, the reflected part we get as a function of x and t is equal to minus sign because of this the coefficient of reflection, which is minus 1, and then this expression incident wave, which is cos omega t, and x we have changed this to minus x minus kx plus phi. So yes, so overall this is our expression for reflected wave. Now if I want to calculate the overall wave function, so this should be the sum of the incidence wave function x and t plus the reflected function of x and t. Yes, let's add them up and we get, so this coefficient of a, so a is the amplitude here in both of the cases, and cos omega t plus kx plus phi, and minus this quantity a cos of omega t minus kx plus phi. Now we can take this a common, and using some simple mathematics in which we can write it like cos omega t plus phi plus kx and minus cos omega t plus phi minus kx. So this will become an equation like we can say this is cos a plus b minus cos a minus b. If I further simplify this, this will become like this, minus 2a sin omega t plus phi into sine of kx. So this is the overall function which is composed of the incident and the reflected wave. Here we can also understand this, that this can be looked at from the 2 point of views. So one wave is going towards the wall and another is reflecting back. One wave is going toward the wall and the reflected wave is coming back. Overall, because of their superposition, we are getting one wave. This is the standing wave. Why we call this a standing wave? So first of all, this can be looked from two perspectives. Number one, that if we fix the value of x at a certain point, if I fix the value of x, we will observe that this point is moving up and down, and the time period of this up and down will be 2 pi by omega. And from the other perspective, if I freeze in time, I freeze in time this picture, so I will get a particular wave pattern. So this wave pattern I will observe through this part sine omega t plus phi. So if I freeze time, in that case I get a particular wave pattern. So this is the another way to study this. So either by freezing the space or by freezing the time, in both ways we can study this and observe the wave pattern in this. Standing wave has a particular character. Why a particular wave should be called as a standing wave? We will discuss on this question after a short break.
हाय, आई एम मनीषा सिंगला। इनऑर्गेनिक और ऑर्गेनिक के कुछ डिफ़िकल्ट कॉन्सेप्ट्स को आसानी से समझाने के लिए मैं आ रही हूँ S.chand अकेडमी में। तो अगर आप हमारे वीडियोस को देखना चाहते हैं तो सब्सक्राइब ज़रूर कीजिए।
Welcome back to S.chand Academy. Before going to the break, we were discussing about the wave reflected from a wall, and we discussed about its pattern. So this is minus 2a, one is time part sine omega t plus phi, and one is space part sine kx. So if either we fix in space, in that case we can observe the variation in time, and if we fix in time, we can observe the variation in space. Overall, the stationary wave has a particular pattern. What kind of pattern is this? That if there is a stationary wave, so it will look, why we call this stationary wave? Because it looks you like a stationary thing. Overall, all the particles of this wave reach to their maximum position at the same time. All the particles of this wave cross the mean position at the same time, and then they adopt the another pattern, reach their maximum once again, and then come back. Overall, all the particles reach their maximum and mean position at the same time. In this way, we can call this a stationary wave, because in our persistence of vision we find it like a stationary thing. Now this is one of the case when you have a wall in front of you. But now let us consider one more case in which you have a pole on which you have a ring, and as you transfer a pulse to it, so you will find that this doesn't remain at this point. So this ring goes up with the wave, and when this ring comes back, this wave will be reflected. So overall, in this way, this wave at its boundary need not to show the 0 point. So it will not remain fixed. So it may show the maximum point even at the boundary as well. So in that case, your wave pattern also flips. That's why in that case we say that the reflection coefficient is equal to +1 instead of -1, which we have already studied in the last part of this lecture. So overall, if we look at this, in that case, when because of a ring, an incident wave and reflected wave, they mix up, in that case we can say that our wave pattern phi xt becomes 2a cos omega t plus phi, and the second part will also be cos kx. This again has two parts, in which you can see one kx part is the space part, which is carrying information about the space, and the second part is cos omega t, the time part, which is carrying information about the time. Now, if you look at both of these patterns, in first case, if the wave is going towards a wall, and in second case towards a pole in which you have a ring. So, overall in that case you have a term sin kx, so that if that x is 0, in that case the part of the string attached to the wall will remain fixed. And in the second case you have cos kx part, in which you have a pole and the ring, and when the x is equal to 0, in that case you can observe the maximum point. So, this is the basic difference between the space part of these two. Now, let us consider a special case in which we study about a closed confinement of all these three possible conditions, in which either two are fixed end, two are open and free ends, and one is fixed and one is open. So, in that case you can see that first is the case in which both walls are fixed and all the strings and the string in this is fixed at both of its points. So, just to show many wave functions, I am drawing many strings. So, this is just to show different states of standing waves. And now the second thing is, here is a ring and here it is fixed. Here it is fixed, here is the ring, and finally the state in which we have both the rings, both the free ends. So, yes. So, consider this is x equal to 0 and this another wall is x equal to L. Similarly, for all case x equal to 0 and x is equal to L, x is equal to 0 and x is equal to L. Now, when both ends are fixed, so the string will remain fixed at these points. Overall, mathematically I can write that, okay, this is sin k. So, instead of this length x, because its length is L, I am writing it as L. So, KL, I am saying, okay, these points are 0. When at x equal to 0 or at x equal to L, this is 0. So, overall this KL should be equal to sin n pi. And from this expression, I can calculate that this wavelength lambda should be equal to 2L by n, should be the wavelength in these standing waves. So, the first of all, if I put n is equal to 1, the lambda should be 2L. It means 2L, it means double the width of this box. Overall, this should be like this. The next is, if n is equal to 2, lambda is equal to L. So, the whole wavelength will be in this box only. Similarly, like this, you will observe pattern like this. For different values of n, you can study this. Now, just because instead of sin kl, you have cos kl at this place. Here one end is fixed and one end has a ring. So overall this cos is at a difference of pi by 2 phase shifted from the sine. So this can be considered as the same function, but just a shifted function. Overall in this case, so KL should be equal to n plus half of pi instead of n pi in this case, just because cos is a shifted wave function. And finally what should we get out of this? So the first wave pattern you will observe like this, the next wave pattern you will observe like this, and the next wave pattern you will observe like this. So overall at the free end you are not going to set it to 0. Overall you are remaining at the maximum point where the end is free. Similarly, when both the ends are free, in that case your first position will be like this when both the ends are up, and then one end is up and another end is also down by the same phase difference. Again the ends are not setting at point 0, they are going to their maximum positions. And similarly other waves can also be explained like this. So in this way the standing wave between two walls can be explained. Overall, if we sum up this lecture, so we started with the consideration that a wave is coming and striking on a wall, and this is completely reflecting back. Overall the reflection coefficient is -1. Considering that, we solved this expression. After that we considered that this wave which is reflecting back now is in a different situation. When there is a ring and there is a free end, the ring can move up and down. Overall the phase also changes, and finally the reflection coefficient you get is +1. Considering these two, you get these two expressions, and when you add them you get a standing wave. And we also defined what is standing wave. And then we took three situations in which when both walls are the fixed end. In one case one is a fixed end and one is a free end, and in third case both are free ends. Overall in this way we studied the wave patterns, the standing wave patterns in all these three situations. If you wanna study in depth about these topics, you can refer this book by S.chand Publishing. You can also find its ebook links in the description box. Please don't forget to like, share and subscribe. Stay connected. Have a good day.